Good morning, good afternoon, and good evening, everyone. I wish to thank the organizers and sponsors for SCOMathon for once again inviting me back to give a presentation in this awesome global virtual event for the 7th year since 2020. The topic I'm presenting today with my co-presenter, Vincent from Infront Consulting Asia, is titled Security Copilot, AI Agents, and SCOM, a Better Together Evolution. Here's a little bit about me. My name is Wei Hao Lim. You can call me Wei. I am a Microsoft Principal Cybersecurity Cloud Solution Architect based in Melbourne, Australia. I specialize in multi-cloud monitoring, security and AI solutions, and automation design, and am across Microsoft Security Copilot, Microsoft Sentinel, Defender, SCOM, Azure Monitor, and Azure Cost Management. I work mainly with enterprise customers to implement and demonstrate the value of Microsoft's security and AI services, monitoring solutions, and help remove technical blockers, drive success, customer confidence, usage, and consumption of our products and services to help make our customers more secure. It is such an honor to be here today to speak to you all on this topic that I'm very passionate about, and a security product that I have continued to be heavily involved in since 2024, which is Microsoft Security Copilot.
Hi, my name is Vincent. I'm the principal consultant from Infront Consulting Asia. I'm specialized in multi-cloud monitoring, data visualization, and automation design, particularly through the use of the Microsoft solutions such as SCOM, Azure Infrastructure, Azure Monitor, and Azure Cost Management. I work alongside enterprise clients to implement and demonstrate the advantage of Microsoft offering, how to tackle technical obstacles, and improve customer success and trust, and also the overall operation of our product and services.
The objective for this session is to explore the benefits of extending your SCOM foundation using modern agentic automation and observability capabilities across Security Copilot and Azure to unlock greater value from existing monitoring investments, and how SCOM insights can be elevated beyond traditional monitoring, enabling more autonomous, outcome-driven security and availability capabilities that strengthen organizational resilience. Then, I would like to showcase an evolved operationalized solution that builds on last year's SCOM and Security Copilot integration, moving beyond real-time querying toward sustainable, production-ready use, allowing Security Copilot agents to directly evaluate and reason over current SCOM telemetry, supporting autonomous, scalable, and sustainable security and availability operations. Here's the agenda for today's session. The agenda is organized under the following topics. We will first do a quick overview of Security Copilot and its agent-driven capabilities and how they enable autonomous reasoning and action. I will then go straight into a demo on how we can use Copilot agents to reason over current SCOM telemetry to detect and assess coordinated attack activity in a potential attack campaign. Following the demo, we will walk through the solution at a high level, covering data flow and orchestration, before diving into the key building blocks that enable a balanced, operationalized, and sustainable implementation. This year, Security Copilot has evolved beyond being just an assistive AI experience. At its core, Security Copilot is still about helping security and operations teams work faster and more effectively. But the how has changed. We are now seeing a shift from Copilot simply responding to questions to agents that can continuously evaluate, reason, and act on behalf of teams. Instead of manually stitching together signals from different tools, Security Copilot can reason across security, operational, and environmental contexts, including data coming from platforms like SCOM. This allows teams to move from isolated investigations to outcome-driven operations where insights are continuously assessed and turned into meaningful actions. Throughout this session, you'll see how this evolution enables a more balanced and sustainable approach, one that combines human decision-making with agent-driven automation without replacing existing investments. One of the key strengths of Security Copilot is how easy it is to work with without forcing teams to change how they already operate. Security Copilot provides both a standalone experience where teams can reason across multiple domains and embedded experiences where Copilot capabilities are available directly inside existing Microsoft security tools like Defender, Entra, Intune, and Purview. This means analysts and operators don't have to context switch or learn a complete new interface and can interact with Copilot wherever they are across these tools. What's changed since last year is how extensible this experience has become. Security Copilot now supports agents, custom promptbooks, plugins, and integrations that allow organizations to bring their own data, workflows, and logic into the Copilot experience. This extensibility is critical for moving from one-off investigations to repeatable, sustainable operations. And it's what enables the custom agent scenarios you'll see later in the demo, where Copilot reasons directly over live operational telemetry from systems like SCOM. Last year, we introduced the idea of Copilot helping analysts automate specific security tasks. This year, the conversation shifts to agents. Security Copilot agents are not just scripted automation or static playbooks. They are autonomous and adaptive, designed to continuously evaluate signals, reason over context, and take action within defined guardrails. What's important is that agents fit naturally into existing workflows. These agents are purpose-built for security and IT operations. They handle high-volume, repetitive work, such as triage, assessment, and prioritization, so that human teams can focus on higher value decisions. As we move through this session, you'll see how this agent-driven model becomes especially powerful when combined with rich, current telemetry from platforms like SCOM, enabling more timely, context-aware, and sustainable operations. Security Copilot agents aren't a single fixed capability. They are a platform model. At one end, Microsoft provides built-in agents designed around common high-volume security and IT scenarios. These agents are deeply integrated into Microsoft security products and help teams automate repetitive work out of the box. But the real power comes from custom agents. Custom agents allow organizations to bring their own context, data sources, and operational logic into Security Copilot. They are designed to reason over environment-specific signals, not just generic security data. That is exactly what we'll be showcasing in the demo. A custom agent that reasons over current SCOM telemetry, enabling more timely, context-aware, and operationally meaningful outcomes. Beyond that, Security Copilot also supports a growing ecosystem of partner-built agents, allowing organizations to extend agent-driven operations into third-party tools and platforms without breaking existing workflows. Now that we have covered the concepts, let's jump into the demo and see how this actually works with real SCOM data and agent-driven reasoning. In this example, we'll start in the Microsoft Security Copilot standalone portal and check in on my SCOM Security Solution Orchestration Agent. First, we'll review its latest SCOM security alert collection status and the most recent SCOM security alerts from the past 5 to 10 minutes. Then, we'll see whether the agent has identified an attack campaign, specifically a PowerShell-driven credential theft sequence that could lead to ransomware, based on security alerts collected over the past 24 hours for a critical application in my organization called Contoso. Contoso's health, security, performance, and alert telemetry is generated by a custom SCOM management pack created specifically for this application. The latest security and performance alerts are then surfaced to Security Copilot, enabling the agent to evaluate the telemetry and drive the attack campaign detection outcome. So, let us start here at the Security Copilot standalone experience. Go to the agent page. Here, we see our security solution orchestration agent. Click on Go to Agent. We see further details about this agent, like the agent description, whether auto trigger is turned on, and the frequency, the permissions, the identity the agent is running under, what are the plugins used by the agent, and the agent activity pane showing the agent's previous run history. This agent is currently paused. To run it, I can either turn on the trigger for the agent to run every 5 minutes, or just a one-time manual run as shown here compared to automated. So this is the main Security Copilot agent responsible for orchestrating the collection of SCOM security alerts and coordinating the detection of potential attack campaigns across the environment. And so what happens when this agent is triggered to run? First, it calls upon its first helper agent in Security Copilot to collect the most recent security alerts for the Contoso application from my integrated SCOM environment. So the helper agent has predefined instructions to use a custom and special skill in Security Copilot to trigger an Azure Logic app, which kicks off an Azure Automation Runbook in my subscription. The PowerShell Runbook connects to my integrated SCOM environment via the SDK service using SCOM PowerShell commandlets and retrieves the most recent list of security alerts for the Contoso application. Upon retrieval, these SCOM alerts for Contoso are closed as well and tagged with processed by SCP in their custom field 10 property. What's different from the approach I showed last year is that the list of SCOM security alerts is no longer sent directly back to Security Copilot for immediate evaluation by the model. Instead, the alerts are ingested into a custom table in an Azure Log Analytics workspace using the Log Ingestion API, configured with a dedicated DCE and DCR. As a result, Security Copilot no longer needs to wait for the full alert payload to be returned from the HTTP trigger in the Logic app. It only receives confirmation that the workflow has been successfully triggered, along with the current execution status, typically running, while the PowerShell runbook continues retrieving alerts from the connected SCOM environment via the SDK service, which can take longer to complete. Once the Logic app returns the trigger acknowledgement and current execution status, the main Security Copilot agent proceeds to the next step and directly invokes a custom KQL plugin skill. This skill queries the custom Azure Log Analytics table for the most recent SCOM security alerts for Contoso that were ingested within the last 5 to 10 minutes and returns the results to the agent for evaluation. If the query returns no result, the agent wraps up and completes its execution. Otherwise, it moves on to the next step and invokes its second helper agent, passing these recent alerts as the input for further analysis. In the final step, the main Security Copilot agent invokes its second helper agent to perform attack campaign detection, specifically looking for an attack campaign involving a PowerShell-driven credential theft leading to ransomware scenario. The helper agent takes the recent SCOM security alerts from the previous step as its initial input. Guided by a comprehensive set of predefined instructions, this helper agent first invokes another custom KQL skill. This time, the skill queries the custom Azure Log Analytics table for all SCOM security alerts from Contoso collected over the last 24 hours, providing a broader historical context for analysis. The analysis is designed to recognize partial, delay, or out-of-order evidence, acknowledging that the most recent alerts may represent mid or late stage activity rather than the initial compromise. When the detection criteria are met, the agent produces a structured output that includes a campaign ID, identified attack phases, involved hosts and users, earliest and latest observed timestamps, observed meter tactics, and an overall confidence level. Throughout this process, the key principle is to treat the attack campaign as a behavioral pattern rather than assuming a linear or sequential progression. Now let's quickly switch to the integrated SCOM environment and take a look at the SCOM alert view in the operations console. Here we see that the alert view has a few security alerts generated by the alerting rules in the custom management pack that is monitoring the critical application within the last 24 hours. So let's go back to the Security Copilot standalone experience to our agent page. I will now manually trigger the agent to run here. As mentioned earlier, it calls upon its first helper agent in Security Copilot to trigger an Azure Logic app. Here is the Logic app in my subscription. I name it Get SCOM Security Alert with an LA in the prefix. You can see that the Logic app is now running. And when we double click into the latest run, we see that the Azure Automation PowerShell runbook that connects to my integrated SCOM environment has been triggered and has finished the run. Next, I go to this PowerShell runbook in which I name as the same with RB as the prefix. Here, we can see that the runbook job has completed its run as well, where it has currently completed retrieving the most recent list of security alerts from Contoso from my integrated SCOM environment via the SDK service using SCOM PowerShell commandlets. As mentioned earlier, upon retrieval, the SCOM alerts from Contoso will be closed as well as tagged. Now let's switch back to the SCOM environment. And take a look at the SCOM alert view in the operations console. Here we see that the few alerts that we saw just now in the alert view are no longer in the active alerts view, which means that they have been closed. They should be in the closed alert view and are tagged with this tag here. Let's go back to the standalone experience and check on the status of our main orchestration agent in the agent activity page. We see in the result pane that step 1 has completed with the following message. The logic app workflow is running and collecting alerts. Step 2 here is completed as well. The main agent checked for the most recent SCOM security alerts for Contoso. No new records were found in the collection. This is because the first time the main agent is triggered, it won't find any recent alerts in log analytics, as there's a short delay while the security alerts retrieved by the logic app are ingested and become queryable in the workspace. So if I manually run the agent again now, or after a few minutes, it should detect the alerts that were ingested a few minutes earlier. I will now manually run the agent again. This time we will stay in the agent activity page of the main agent and observe the result of this run. As usual, we see in the result pane that step 1 has completed successfully. But this time, we can see that step 2 completed with a list of the most recent SCOM security alerts for Contoso that were collected within the last 5 to 10 minutes. For this reason, when the agent is operationalized and scheduled to run automatically, a 5-minute execution interval is recommended to account for ingestion latency and ensure consistent results. Finally, when step 2 completes, we can also see the investigation output and findings in step 3 when it completes. Here, the second helper agent performed an attack campaign detection for an attack campaign involving a PowerShell-driven credential theft leading to ransomware scenario. As the detection conditions are met in this instance, the agent produces a structured output that includes a campaign ID, identified attack phases, involved hosts and users, earliest and the latest observed timestamp, observed mutual tactics, and an overall confidence level. In this case, it's medium. Now, let's go to the usage monitoring page in the standalone experience to check the security compute units or SCU consumption after running our main orchestration agent twice. We see that each run of the main agent consumed less than 0.1 SCUs despite the complexity of the workflow, including multiple agent steps, KQL queries, and campaign level analysis in each run. This is a noticeable improvement compared to last year's approach, where raw telemetry is directly returned into Security Copilot for immediate evaluation by the LLM within a single prompt. That model required more compute because the LLM was responsible for both retrieval and reasoning in one step. I recall it was around 1 SCU per prompt back then. To wrap up the demo, what you have just seen is how Security Copilot agents can move beyond simple alert summarization to reason over live operational telemetry from SCOM by combining recent signals with broader historical context. The agent is able to detect complex, non-linear attack patterns that would be difficult and time-consuming to identify manually. This approach allows teams to focus on outcomes such as identify attack campaigns rather than stitching together individual alerts. Importantly, this is built on an existing SCOM foundation, extending its value rather than replacing it. This is a practical example of how agent-driven operations can scale security and availability insights in real-world environments. What's also important to highlight is the operational efficiency of this design. Even with multi-step execution and helper agents involved, each run of the main agent consumes less than 0.1 SCUs, which is significantly lower than last year's approach where telemetry was pulled directly and evaluated by the LLM in a single interaction. Now that you have seen how this works from an operator's perspective, let's take a step back and look behind the scenes at how this solution is put together, starting with the data flow and orchestration that make this agent-driven approach possible. This is the high-level solution architecture and data flow diagram I shared last year. And many of the foundational components are intentionally still the same. We are still retrieving environment-specific security telemetry from SCOM using Azure Automation Runbooks, triggered through a logic app, because that remains a reliable and scalable way to access SCOM data. What's changed this year is what happens next. Behind the scenes, the foundation of the solution is intentionally familiar. SCOM is still the system generating environment-specific security, health, and performance telemetry, and that remains the backbone of the solution. We are still using Azure Logic Apps and Azure Automation Runbooks to securely retrieve that data from SCOM because this approach is proven, scalable, and works well in hybrid environments. What has changed this year is how the data is used once it's collected. Instead of returning raw alert data directly into Security Copilot for immediate evaluation in a single interaction, the telemetry is persisted in Azure Log Analytics using custom tables. So it becomes queryable and reusable across time windows. On top of that, Security Copilot Agents now orchestrate the workflow end-to-end, triggering collection, checking status, querying recent versus historical telemetry, and performing campaign-level reasoning as a continuous, operationalized process rather than a one-off query and summarized flow. An important outcome of this design is improved efficiency. The agents only consume compute when analysis is actually required, even with multi-step execution and helper agents involved. This approach uses significantly fewer security compute units or SCU than last year's prompt-centric model, making it far more practical to run continuously at scale. Now that you have seen the solution in action, let's dive into the key components behind the scenes and walk through how data flows from SCOM through automation and into agent-driven analysis within Security Copilot. Let's start with the SCOM environment and access layer, which is intentionally very similar to what I showed last year. This part of the solution continues to work with a classic SCOM environment. We still rely on the SCOM SDK and connect via the management server FQDN using the new SCOM management group connection commandlet with credentials assigned to the appropriate SCOM roles. Once that connection is established, we use PowerShell scripts with standard SCOM commandlets to retrieve monitoring and security telemetry from the environment. This is exactly the same proven access pattern as last year. What's important is why this hasn't changed. Rather than redesigning how we access SCOM, this year's solution builds on it and shifts the innovation to how data is orchestrated, persisted, and reasoned over by AI agents. The next key component is the automation account and PowerShell runbook. And this is another area where the foundation remains intentionally consistent with last year. We still start by creating an Azure automation account and a PowerShell runbook with clear and meaningful naming, so it's easy to understand what each runbook is responsible for as the solution grows. As before, the SCOM PowerShell modules are added under the PowerShell 5.1 runtime in the Azure Automation Accounts shared resources, and the SCOM access credentials are securely stored and managed there as well. This keeps authentication and module management centralized and reusable. Inside the runbook, we first add the prepared script that collects the required monitoring and security telemetry into the PowerShell runbook. Then, we import the SCOM modules, retrieve the stored credentials, establish the SDK connection to the SCOM management server FQDN before we then publish the runbook. What's different this year is instead of being tightly coupled to a single Copilot interaction, the runbook now acts as a durable data collection mechanism that can be triggered asynchronously by logic apps and coordinated by Security Copilot agents. This separation allows the solution to scale, tolerate longer execution times, and support repeated operationalized analysis rather than one-off queries. The next component is the logic app, and once again, this is an area where the core design remains familiar, but the way it's used has evolved this year. As before, we create an Azure Logic app with a meaningful name and use it as an orchestration layer between Security Copilot and Azure Automation. The Logic app is configured with an HTTP request trigger, which gives us a unique callback URL that can be invoked by a special type of skill from Security Copilot. Inside this Logic app, we still use Azure Automation connectors to create a job for the specific PowerShell runbook, and if required, retrieve job output. The create job action is linked directly to the automation account and runbook we created earlier. What's different this year is that the Logic app no longer needs to synchronously return the full runbook output to Security Copilot. Instead, it acknowledges that the job has been successfully triggered and returns execution status, allowing the workflow to continue running independently. This change is important because it removes type coupling between execution time and Copilot interactions. It allows long-running SCOM data collection to complete in the background, while Security Copilot agents coordinate follow-up analysis once the data has been ingested and is ready to be queried. The next key component is Azure Log Analytics, and this is where the architecture meaningfully evolves compared to last year, as seen here. Previously, telemetry retrieved from SCOM was evaluated immediately within a single Security Copilot interaction. This year, the data is first persisted in Azure Log Analytics, making it durable and reusable across different time windows. By ingesting alerts and telemetry into a custom table in Azure Log Analytics, we deliberately decouple data collection from analysis. Instead of reacting to a single snapshot in time, this allows Security Copilot agents to reason over both recent and historical telemetry as part of an ongoing detection process. From an implementation perspective, this starts with creating a log analytics workspace and defining a custom table with a schema that matches the telemetry we want to ingest. We then create a data collection endpoint, or DCE, and a corresponding data collection rule, or DCR, which enforces that schema and provides a controlled ingestion path into the workspace. Finally, in the Logic app, we add an HTTP action that uses the DCE ingestion URL along with the DCR stream name and immutable ID to write the collected telemetry into the custom table. And this is an example of what that HTTP ingestion step looks like in the Logic app. The final key component is where everything comes together. Security Copilot agents, plugins, and skills. Agents act as the orchestration layer for the solution. They coordinate how and when telemetry is collected, what data should be analyzed, and how findings are correlated across time. Plugins and skills are what allow those agents to interact safely with the rest of the environment. They provide control access to Logic apps and services like log analytics, and encapsulate specific actions or queries that the agent can invoke as needed. From an implementation perspective, this is where we wire the intelligence into the platform. We start by creating a custom plugin that the Security Copilot agent can use to access its skills. The plugin acts as the contract between the agent and the underlying systems it needs to interact with. Within the plugin, we add an Azure Logic Apps base skill, which allows the agent to invoke the Logic app workflow responsible for orchestrating the data collection and ingestion. We then add KQL base skills to the same plugin. These skills query the custom table in Azure Log Analytics, giving the agent access to both recent and historical alert data in a controlled, repeatable way. Once the plugin and skills are defined, we create the agent workflow using the agent builder, referencing those skills as part of the agent's execution plan. On the screen, you can see examples of what this looks like in practice. This is a YAML or YAML plugin definition for the Logic app skill. And here is the YAML definition for the KQL skills, including the query it runs against the custom table. Both are in the same custom plugin. This is the agent YAML definition itself. You can see the instruction set that guides the agent's behavior, how it calls the two helper agents, and how the second helper agent is defined with the more detailed and specialized instructions to reason over the data and detect an attack campaign. As the final step, the same YAML definitions can be further refined directly in the agent builder page within the Security Copilot standalone experience. From there, you can fine-tune the agent's instructions, control when and how the agent is invoked, configure the required permissions, and test the agent before publishing it. Once the agent is published, an agent identity must be configured before it can run. After that, the agent becomes available to be triggered and managed from the agent's page. Before wrapping up, it's important to briefly cover identity and access management, because this is both a security requirement and a strength of the solution. On the Azure side, the Logic app uses a system-assigned managed identity, which means there are no credentials, secrets, or keys embedded anywhere in the workflow. Access is entirely identity-based. That managed identity is then granted only the permissions it needs. These permissions can be scoped either at the individual resource level or at the resource group level if all components live in the same resource group. On the Security Copilot side, the main agent runs under an Entra ID identity. One important requirement here is that the Security Copilot tenant must be the same tenant as the Logic app and supporting Azure resources. And the user or agent identity must have access to that tenant. If the Logic app exists in a different tenant, Security Copilot will not be able to invoke it. Finally, the Entra ID identity used by the agent needs at least log analytics reader permissions to query the custom table in the log analytics workspace. Finally, to wrap up, this session showed how a SCOM environment can be taken beyond traditional monitoring and operationalized as part of modern security detection using Security Copilot. Last year, the focus was on enabling users to query real-time SCOM data through natural language prompts and receive contextual summaries inside the Copilot experience that help make SCOM data more accessible and easier to reason across. This year, the approach evolves significantly. Instead of relying on one-off prompts, Security Copilot agents now orchestrate how telemetry is collected, persisted, and analyzed over time. By reasoning across recent and historical data, agents can detect attack campaigns rather than just summarize individual alerts. This solution is also more efficient, more scalable, significantly less compute usage, and practical to run continuously, not just during investigations. Importantly, this is all built on existing SCOM capabilities. Nothing is replaced. Instead, SCOM's value is extended, internal knowledge is operationalized, and security teams are empowered to focus on outcomes rather than stitching data together manually. In short, this is an example of how agent-driven operations transform Copilot from a reactive assistant into an operational detection capability, ready for real-world enterprise environments. I would like to sincerely thank each and every one of you for taking the time to attend this session. Your presence, support, and encouragement truly mean a lot to me, and I'm deeply grateful for your continued engagement. Please enjoy the rest of the sessions in this awesome virtual event. Thank you.